Your body is built for Earth, designed over millions of years to thrive in the gentle but constant pull of gravity. Gravity shapes you in every way, from the way you walk to how your organs function. It keeps you grounded, literally and figuratively, and it constantly tells your muscles to stay strong, to resist the downward pull with every step you take. Your bones, too, are always working against gravity, staying dense and sturdy so you can move, jump, and run. Even your body fluids, your blood, water, and everything in between, know where to go because gravity guides them, helping your heart pump and your brain function. But what happens when you leave Earth behind and enter the vastness of space, where gravity is almost non-existent? Suddenly, your body is in microgravity, a world with new rules where up and down no longer exist, and your senses are thrown off balance. Muscles and bones, no longer needed to fight gravity, start to weaken and shrink. Without the daily challenge of Earth's pull, your body quickly begins to change. Your body, always adapting, begins to break down what it thinks you don't need. Cells that once built strong muscles and bones now start to recycle them. This is a huge challenge for astronauts, especially on long missions, where every day in space means more changes to their bodies. If you stopped using your legs for a year, they'd waste away, just like what happens to astronauts in microgravity, but to their whole bodies. In space, your entire body gets that message, and it happens much faster than you might expect. That's why scientists are racing to find ways to trick the body into thinking it's still on Earth, using exercise, special suits, and even virtual reality. This isn't just for short trips. Missions to Mars could last 3 years with astronauts far from home and Earth's gravity for the entire journey. That's a long time for your body to be in microgravity, and the changes can be dramatic, affecting everything from your bones to your immune system. Understanding these changes is key to keeping astronauts healthy, both in space and when they return to Earth. Without healthy explorers, our dreams of reaching other planets stay dreams. The human body is the ultimate limiting factor in space travel. The International Space Station is our laboratory for solving these puzzles, orbiting above us as a test bed for future exploration. Every experiment there helps us learn how to protect the human body in space and brings us closer to safe, long-term missions. The health of astronauts is the key to unlocking the solar system, opening the door to new worlds and discoveries. If we can't keep them strong, we can't go further. Protecting their bodies is protecting our future in space. That's why this research matters, not just for space, but for all of us. What we learn helps people on Earth too, from patients in hospitals to the elderly. The future of exploration depends on it. By understanding gravity's role, we unlock the next chapter of human adventure. The moment astronauts reach orbit, their bodies start to change in ways that are both fascinating and challenging. Space is an environment unlike anything on Earth, and the human body must quickly adapt to survive. Without gravity pulling fluids down, they rush to the head and chest, creating a feeling of pressure and congestion that's impossible to ignore. Faces puff up, legs get skinny, and astronauts often feel stuffy and off balance, as if they have a constant head cold. Even simple movements can feel strange at first. Muscles, especially in the legs and back, quickly weaken. This is muscle atrophy. Daily exercise is essential to slow this process, but it can't stop it completely. Bones lose density, thinning much faster than on Earth. Months in space can mean years' worth of bone loss, increasing the risk of fractures. The immune system gets confused, sometimes weakening, sometimes overreacting. Astronauts can become more vulnerable to illness or develop allergies they never had before. Sleep becomes a struggle, with 16 sunrises and sunsets each day disrupting the body clock. The constant hum of machinery and lack of natural darkness make true rest difficult. Poor sleep means fatigue and mistakes, dangerous in space where alertness is critical for safety and success. The brain's balance system goes haywire, causing space sickness for many. Nausea, dizziness, and disorientation are common in the first days. Over time, the brain adapts, but vision can suffer. Some astronauts notice their eyesight blurring, making it hard to read or focus. Fluid pressure in the skull can flatten the eyeball, leading to blurry vision that sometimes lasts long after returning to Earth. Some astronauts' eyesight never fully recovers, a reminder of how spaceflight can leave lasting marks. Every system in the body is affected by microgravity, from the heart and lungs to the brain and skin. Scientists study these changes to keep astronauts safe, developing new ways to monitor and protect their health. The more we learn, the better we can protect future crews venturing farther from home. Space changes us, and we have to be ready for the unknown, adapting our bodies and minds for the journey. That's the challenge of leaving Earth, to explore, to endure, and to return home changed forever. In space, your muscles and bones start to waste away. The absence of gravity means your body no longer has to fight against weight, and this has dramatic effects on your health. Postural muscles, calves, thighs, lower back, lose strength fast. These are the muscles that keep you upright on Earth, but in microgravity, they barely get used. Without gravity, they have nothing to do, and atrophy sets in. Even simple movements become effortless, so muscles shrink from disuse. Astronauts can lose up to 20% of their muscle mass in just a few months. That's like aging decades in a fraction of the time. Returning to Earth, they often need help just to walk. Their bodies have forgotten how to support their own weight. Bones are even more at risk. The skeleton, which is constantly being rebuilt, depends on the stress of gravity to stay strong. On Earth, bones rebuild under stress. In space, that signal vanishes. The body thinks the bones aren't needed anymore. Bone-building cells slow down while bone-dissolving cells keep working. Over time, this imbalance leads to rapid bone loss. Astronauts lose bone density at a rate that would take a year on Earth, sometimes as much as 1% per month. Bones become brittle, raising the risk of fractures. Even a minor fall could have serious consequences after a long mission. Some bone loss may be permanent, even after returning home. Recovery can take months, and some astronauts never fully regain their original bone strength. This is a huge concern for Mars missions. Long journeys mean more time for muscles and bones to weaken. Weak bones could make it impossible to explore new worlds. Imagine landing on Mars, only to find you can't even stand. Protecting muscles and bones is one of NASA's top priorities. Specialized exercise routines and equipment are constantly being developed. Every day in space, the body is fighting to stay strong. Astronauts spend hours exercising to slow the loss, but it's a constant battle. Without solutions, our journey to the stars could end before it begins. The human body is the ultimate limiting factor in space exploration. That's why this research is so urgent. Every discovery brings us closer to safe, long-term missions beyond Earth. The future of exploration depends on strong bodies and the science that keeps them that way. Arriving in space, your balance system is thrown into chaos. The inner ear's fluid floats, confusing your brain and causing space sickness. About half of astronauts feel dizzy and nauseous at first. The brain adapts, but returning to Earth means relearning balance all over again. Fluid shifts also affect the heart, which doesn't work as hard in space. The body gets rid of extra fluid, leaving astronauts slightly dehydrated. Back on Earth, the heart suddenly has to work harder, causing problems. Sleep is another struggle. 16 sunrises and sunsets a day disrupt the body clock. The constant noise and lack of a normal day-night cycle make rest difficult. Poor sleep leads to fatigue and moodiness, risky in a small, confined space. Managing these changes is critical for astronaut health. Every day in space is a test of the body's ability to adapt. Many astronauts return from space with blurry vision. The culprit is fluid shifting to the head, raising pressure inside the skull. This pressure flattens the eyeball and swells the optic nerve, called SANS. For some, vision returns to normal. For others, changes are permanent. Scientists are testing solutions, like suction sleeping bags and special goggles, to pull fluid away from the head. Protecting eyesight is mission critical for deep space travel. Without clear vision, astronauts can't do their jobs or land safely. Solving this problem is essential for Mars missions. Spaceflight confuses the immune system. Some defenses weaken, while others overreact. Dormant viruses like chickenpox can reactivate in astronauts. The closed environment of a spacecraft makes it easy for germs to spread. A simple cold in space can become a serious problem. Scientists monitor immune changes with blood and saliva samples. Good nutrition, sleep, and stress management are vital countermeasures. Researchers are testing supplements and medications to boost immunity. Keeping astronauts healthy means keeping their immune system strong. Every mission teaches us more about protecting the body in space. The immune system is our frontline defense on Earth and beyond. Exercise is the best defense against muscle and bone loss in space. Astronauts work out 2 hours a day using special machines that create resistance without gravity. The AR-ED machine lets them do squats and deadlifts, simulating heavy lifting. Treadmills and bikes with harnesses and bungees provide cardio and bone impact. Every workout is tracked and adjusted by doctors on Earth. These routines are essential for staying strong and healthy. What we learn in space gyms helps people on Earth too, especially the elderly and bedridden. Exercise science from space is changing medicine everywhere. Without daily workouts, astronauts would quickly weaken. The space gym is a lifeline for long missions. We can't test everything in orbit, so much research happens on Earth. Bed rest studies simulate microgravity, tracking muscle, bone, and immune changes. Volunteers lie in tilted beds for weeks, helping scientists test new countermeasures. Isolation is another challenge. Simulated missions in habitats like Hera or Antarctica prepare crews for deep space. Underwater and desert habitats mimic the danger and confinement of space. These analog missions teach us about teamwork, mental health, and survival. Every simulation brings us closer to safe, successful Mars missions. Picking the right crew and keeping them healthy is as important as any rocket. Earth-based research is the foundation for exploring the stars. We're practicing now for the real journey ahead. Mars is within reach, but the journey is our biggest health challenge yet. 3 years in deep space means more radiation, muscle and bone loss, and psychological stress. Astronauts will be far from help, needing advanced medical tools and self-reliance. Mars' gravity is weak. Will it be enough to stop bone loss? No one knows. Toxic Martian dust, limited resources, and physical labor add to the risks. Every ISS experiment and Earth simulation prepares us for this mission. New medicines, exercise machines, and support systems are in development. The first Mars explorers will be walking experiments, teaching us what's possible. Their health will decide if we can become a multi-planet species. The next giant leap is not just to Mars, but in understanding the human body. Keeping astronauts healthy is the key to reaching new worlds. The future of exploration depends on what we learn now. Mars is the test, and we're getting ready.